Now let's talk about vector multiplication. So there's two ways we can do vector multiplication. You might have heard of these. They're quite well known, and their name does tend to get thrown around sometimes. We can either do what we call dot product, or the cross product. And these are two different ways to measure or to multiply vectors together. And I'm going to tell you up front right now, and then I'm going to explain them. When we use the dot product to multiply two vectors together, the result is a scalar. So when we multiply vectors together using the dot product method, we get a scalar. And when we multiply vectors together to using the cross product method, the result is a vector. It's a vector, so that means it has both a magnitude, and a direction. So it has both. I'm going to start off by explaining the dot product. So something we're going to talk about later is this thing called work. Now work is equal to force. So force is a vector quantity times displacement. Displacement is a vector quantity. And this is the multiplication of two vectors together. And don't worry, we're going to talk about work a lot. So right now we're just kind of talking about the dot product rule. And maybe I should say that. So this is going to be dot product. So we're talking about the dot product. And work is an example of something being multiplied by two vectors. So to get work, we multiply two vectors together. And then we use the dot product rule to get work. So that means work is a scalar. It's a scalar quantity because whenever we use the dot product, the result is a scalar. So let's say we want to multiply force times our displacement. And notice we're using a dot. So it's very important we get this notation right. That is going to be equal to the magnitude, or the absolute value, the magnitude of F, vector F, or force, times the magnitude of displacement. And then we're going to multiply everything by the cosine of the angle. So let's draw a triangle right here. Let's draw a diagram. Let's say this here is our force. Let's say force is equal to, let's say it's equal to 200 newtons. And let's say in applying this force, we're able to move whatever we're moving, something like 50 meters, I guess. 50 meters, just off the top of my head. Okay, now we're left with this. Now what we want to do, and we're also given this angle, let's say angle 60, so 60 degrees is angle theta. Now we want to know what is work. So how much work was done. So recall that work, a scalar quantity, is going to equal to force times displacement, which is equal to the magnitude of force times the magnitude of displacement times cosine of angle theta. So let's fill in what we know. So we know the absolute value of force is 200 newtons. Is 200 newtons. We know the displacement is 50 meters. And we know that cosine is of angle 60. Okay, so let's multiply what we know. So 200 times 50 is going to give us 10,000. Now, what is cosine of 60? Well, recall in the very first video I posted on this channel, we go over the values of cosine, sine, and tangent functions at different angles. So I'm just going to do a very quick review. So we have different angles. So we could have 0 degrees, we have 30 degrees, 45 degrees, 60 degrees, 90 degrees, and we'll end it there because that's 90 degrees. Okay, and then we have sine of theta, cosine of theta, and I also talked about tangent, but we don't need to know about tangent for this question. So just to fill this out, let's fill this out. So for cosine, we start at 4 over 2. And guys, if you don't know what I'm doing, please check out that other video I posted, because I don't want to spend, another 10 minutes explaining how to make this table. But yeah, check it out. Okay, so we found it. So cos at theta 60, so cos at 60 degrees is equal to root 1 over 2, or just 1 over 2. So we're going to multiply it by 1 over 2, and we're going to be left with 5,000 Newton meters. And that is our answer. Now this is a scalar. It is a scalar because we multiplied using the dot product rule, or the dot product rule. And using the dot product rule always results in a scalar. So we just went over the dot product rule. Now we're going to focus on the cross product rule. So let's write this out. So just to recap, the dot product rule is going to be equal to, so when we talk about the dot product rule, we're talking about, we're talking about vector A times vector B, and that's going to equal the magnitude of vector A times the magnitude of vector B times the cosine of the angle theta. Now when we're talking about the cross product rule, we're going to talk about vector A times vector B. And the notation here is very important. Although both of these things both mean multiplication, just by writing it out and visually, it means very different things. And I'll show you what I mean. This is going to be equal to the magnitude of A, just as we saw before, times the magnitude of B. Now the difference comes in, now we're going to use sine. We're going to use a sine function instead of a cosine. And this is going to result in a vector. This is going to result in a vector. Now there is a mathematical reason why, and I'm definitely going to explain that later, but the place isn't in this video. Maybe in the next video I'll talk about why. But for now, just know that the dot product rule, this is going to result in a scalar, meaning it only has a magnitude, no direction. And this is going to result in a vector, meaning it has a magnitude and a direction. Okay, how are we going to do this? Well, we can do this, for example, here. Let's say we have we have this vector A, and we can have the example is going to be pretty much identical to the last one. Vector, let's call this we can call this B, and maybe this angle is, let's call this 45 degrees. Now to do this, so we're going to do cross multiplication. So the question might ask you, what is the direction of the resultant vector between the multiplication of vector A by vector B? So whenever they ask for direction, so if a question asks you for the direction, we're going to have to use cross multiplication, because remember, direction is a vector quantity. So whenever we're asked for direction, we're going to have to find a vector, and we can only find a vector if we use cross product rules. So A cross B, whoa, my pen is freaking out today, I don't know why. B, so A cross B is going to be equal to the absolute magnitude of A times the magnitude of B, and we're going to multiply all that by sine of angle theta. So let's write out what we know. So we were given, oh, I forgot to give you guys values. So let's say A is equal to 10, keep it easy for us. A is equal to 10, B is equal to 5, and we already were given angle theta is 40, so, or 45. So we know the absolute value of A is 10. We can call this maybe 10 meters per second, and this is also maybe meters per second, I don't know. So 10 meters per second times another 5 meters per second multiplied by sine of 45. Okay, now multiply 10 by 5, you get 50. The sine of 45, again, guys, I went over this in my last video. Sine of 45 is going to be root 2 over 2. So the answer is, we can cross this out, we're left with 25. So 25 times root 2, and that is our answer, and it can be in like meters per second. So that's basically what we're working with here. So this is going to be a vector. Now, you might ask me, okay, cool, so this is the magnitude of the vector, but how do we know what direction it's in? And to find out the direction, we're going to have to use something called the right-hand rule. Now, the next video I post is going to be about the right-hand rule and how to apply it. So if you don't know how to use the right-hand rule, I'll explain it in depth in the next video, and that is going to talk about how to find the direction of this resultant vector.